All right. Currently, several technologies are used to quantify skin rashes by segmenting and analyzing affected areas. Clinicians often rely on visual assessments, questionnaires, dermoscopy, and photo storage methods to track the progression of conditions like dermatomyositis. Visual assessments monitor changes in rash, size, color, and spread, while questionnaires collect patient-reported symptoms. Dermoscopy and photography capture detailed images which are stored and analyzed over time. More advanced methods like k-means divide these images into segments based on color and texture, providing objective measurements for tracking disease progression. These methods allow for more systemic approach to evaluating changes in skin conditions over time. Third para, despite advancements in methods for quantifying skin rashes, challenges remain. Many techniques still rely on subjective clinician judgment and patient-reported data, which can be inconsistent and less effective for detecting subtle changes. Machine learning methods, though they show potential, can often face limitations due to the need for diverse and well-labeled data sets. Without enough high-quality data, the performance of these tools can drop, making it harder to use them in various situations. To address these issues, we propose a semi-automated method using k-means clustering in the lab color space to detect and measure erythema and dermatomyositis. This approach seeks to provide a more consistent and objective measure of rash severity, enhancing disease progression tracking. By creating a detailed patient-labeled and physician-verified, we aim to improve clinical and research outcomes for DM and ultimately lead to better patient management.
Hmm. That's good. So this I really like. These two are much better, and this is something that I'm very happy with, honestly speaking.
Thank
If you
you.
ask me, if you ask me, I would say if we just put in some references, many
Okay.
journals would accept this introduction as final introduction. It's just that, there are like some sentences which are redundant when it comes to when you say redundancy, right? Now, since I've said redundancy, what do you think those sentences are?
Um, let me. mm,
In
I
which
think.
para do you think there are more redundancies?
Okay. Let me. Um, I feel like maybe the second para, and
To
then
go up?
what?
Can you move it up to the
Oh yeah.
second para?
Oh, let me stop sharing.
Currently, several technologies. So currently, so like the starting to the second para, you can use currently, but ideally, we should not start paragraph with such words, right?
Okay.
Because you have the liberty. See, when I'm using currently, you ideally want to use currently when you, what is a second? So you ideally want to use words like currently when you want to continue or give a different context in the same paragraph, right? That's kind of what I see that word for. So I would say just start off with the methods used to quantify skin rashes or the current segmentation methods. The current segmentation methods are dependent on clinician visual assessment, questionnaires, semi, and also some objective metrics include dermoscopy and photo storage methods. And when we have given them context, right? Conditions like dermatomyositis, if you have to bring in another condition like psoriasis or any other rash condition, that's when you put that statement. Or else it's assumed that you are talking about dermatomyositis.
Mm.
So those are the changes that I would make when it comes to that. See, this is just fine tuning and refining, right?
Yeah.
So that's not a major improvement. The improvement is, you refining and you telling the person that you know what you're talking about.
Mhm.
That's about it, right? Now, when it comes to so that is the first part. Then when you say visual assessment, right? Can you tell me the advantage of doing visual assessment?
I would say the advantages are like I would never like you can never say that technology is perfect. There will always be like, you know, room for
Mm-hmm.
error there. So I think with visual
Mm-hmm.
assessments, maybe our eyes can see something that the computer may not. For example, maybe there's parts of the rash, like at the edges that are really light, that a
Mm-hmm.
computer may not be able to recognize, but our own eyes can still see.
Okay, got it. That's perfect. So that's kind of what we need to talk as a benefit when it comes to current technology. That
Mhm.
should be stated, right? With
Oh,
respect to when you say like visual assessment, right, or photography, it doesn't give me information regarding why are you even presenting that to me, in what
mhm,
context. The context is very important. When you say, okay, the context is we are moving towards providing remote or teleconsultation. And
mhm,
you have to become more comfortable with the fact that you're using photographs,
mhm,
right? So with the existing photographs, even without any technology, just looking at it, what are the advantages of doing that? Number one, right? That's the point that you need to strike in when you bring in like photography, right? Then you talk about visually monitoring assessment of change with respect to XYZ. When it comes to questionnaire, you say specifically CDASI.
what?
It's
I didn't
a
hear you.
score. CDASI. C-C score. CDASI. That is a questionnaire,
Mhm,
basically. So you need to give examples of that questionnaire. See, if you have mentioned questionnaire once, right? Second time you give an example of the questionnaire. You should ideally try to not reuse the words in the paragraph,
mhm,
right? See, when you remove those aspects, right, you get more space to put more technical information and more information in general,
mhm,
which will enhance your paper. So how I like to see it is before you put in any sentence, right, you think to yourself saying that, okay, how would I reduce how do I make it smaller and simpler? That's it. It need not be any fancy, smaller and simpler. The more complicated words you use, the more that people will not want to read, right? So that's kind of what I would recommend. That is where these AI is failing, I would say, because
mhm.
yes, it will sound confident, but it has no meaning.
Yeah.
Like, so that's what you need to do.
Mhm,
And when it comes to see, now when I read the other sentence, right? Visual assessment, monitor changes in rash, collect patient reported symptoms. So it is not patient reported symptom. I would say questionnaire to collect patient reported outcomes.
okay.
Symptoms are very different from outcomes. Okay, so there is when you go to med school, you learn that there's a difference. What is the difference between a sign and a symptom? A sign is something that you can see. A rash is a sign,
Yeah.
right? But symptom is something that the patient feels and they're expressing it to you. So that's the difference. Anyway, that's a minor thing. So when it comes to this is where you mentioned dermoscopy and photography capture detailed images which are stored and analyzed over time. So if you are not giving information regarding how they're analyzed, or what is the importance of doing that, then you should not be putting that in the first place.
Mhm.
Okay, so
Mm.
that is one thing that I would suggest. Then then the next is more advanced method. So when it comes to stating as more advanced method, don't call it like advanced. Say that, you know, uh, in pursuit of automation or to simplify skin segmentation. Okay, to simplify skin segmentation, methods like k-means, random forest, or whatever, few methods are there. Those are the methods you have to state.
Mhm.
Okay, here you're stating the methods. So don't go into detail about k-means because you're going to use that information in your fourth paragraph. So you state the other segmentation methods. So you can remove that information and remove the last sentence. The method allows for more systematic approach to evaluating changes in skin over time. See, don't use over time. They're
Okay.
not going to. So most people, I mean, most of the programs, they're not designed to do progression analysis.
Mhm.
Even if you see, right, they're all looking at detection, not progression,
Mhm.
if that makes sense. So that's
Yeah.
something that you have to remove. And one is k-means. That is only one of the methods.
Mhm.
You should look at other skin rash segmentation methods. The other one can be UNet or pre-trained AI models and the some examples with respect to that. Does it make sense?
Yeah.
Yes. Now, how do you start the third paragraph? Right? See, in the second paragraph, you mainly spoke about the existing tools and
Mhm.
how the existing tools are segmenting the disease. Right? In the third paragraph, you talk about the limitation in the bigger context. See, there are pre-trained models, right? Machine learning models that can do image segmentation, skin rash segmentation. Now, in the third paragraph, you need to say what is the biggest requirement for this that you have addressed, right? You need to reiterate the fact that because it is rare disease, the data set is very limited just because it is rare disease, right? Because of that, the you will have challenges in quantifying skin rash. You need to state the challenges, right? Is it because of the models are trained on white skin? Is it because the model can never be as accurate, as well as, some key, drawbacks when it comes to these models? Everything that you have stated in paragraph 2, put in all their negatives. Make sense? And
Mhm.
you say the gap in literature. So the gap in literature is basically you're talking about, hey, these things exist. The gap is so and so. One of the gap is lack of reliable data set, right? But that's not the gap that you really want to focus on,
Mhm.
right? The method only does not exist of a way to segment for skin, dermatomyositis. So you need to talk about, okay, we looked at this method particularly in this way, right? So that's kind of what we are looking for in the third paragraph.
Okay.
So so what you have done with the third paragraph, it's basically also combine the tools for the fourth paragraph. In fourth paragraph is when you say to address these issues,
Oh.
right? And then you say that, okay, we propose a semi-automated k-means clustering in the A space of the LAB color space. Or is it yeah, A space of the LAB color space to segment the redness in that filter.
Mhm.
Okay. So make that as a one single sentence, and then you say that why that is better. Does it make sense?
Mhm.
Now, can you count the words? Like go to tools and count the words
Yeah.
in these two paragraphs.
This second para,
Tools and word count. Yep.
86.
Mm-hmm.
Third para is 142.
142. Okay. So ideally, I think it needs to be somewhere around 350 words.
The third para or the second para?
Introduction.
Oh, just introduction in general.
Yes, introduction in general, around 350 to 500 words. Most of the articles, they prefer that. And then I think if we make these integrations, see, when it is 300, 350 words, right? You write the third para the way you have written. And just give, we have taken a case report, blah, blah, blah. Here we describe a case using so and so. That's about it. That's kind of what you write for the third paragraph. But if it is like 500 words, then you give a dedicated fourth paragraph.
Okay.
Okay. So that's what I would say when it comes to, these two paragraphs. Would you
Mhm.
be what I would say is this is not the assignment, but I do want to see you refine these two paragraphs in the next class.
Okay.
Okay. Now, what I'm going to do is I'm going to show you the presentation that I made,
Okay.
and we'll go over learning aspects. In this class, I am going to show you how to build a questionnaire. Okay. So what are the easy ways to do it, as well as what are the ways that people are doing it right now?
Mhm.
Okay. So let me share my screen. Yep. So that is that. Mm-hmm. And floating and control. Yep. So I have the yep. So I had made a presentation with respect to this was kind of for you.
Could you try and share your screen again?
Oh, okay.
Yeah.
Oh, just a second. Mm, 1 second, I'll be back.
Yeah.
How has your school been, by the way?
It's so there's going on. Like I'm enjoying it, but there's just like so much piling up on top of each other. Like outside of school, like other than just homework, um, I'm like we have like our school clubs and I'm officer in a few. And right now I'm
Mm-hmm.
trying to set up this hygiene drive. Like we're gathering like products to go donate to this to like this organization distributes them to students. Like I'm
Mhm.
trying to set that up. I have to finish registration for another club. My friends and I are starting a mental health related club, so we have to start that. And then I have to practice for my SAT, and then I just have to keep my grades up for my classes.
Quite hard when you try to do many things.
And then I have to volunteer on top of that. So like this is like I wrote down all of the I don't know if you can see it.
Yeah,
Like this
kind
is like
of audible. I
all
mean,
of the stuff that I have to do this weekend is on this note right here.
when do you, I mean, I don't know, it's too much. I remember when I was your age, I used to think you're in 11th grade now, right?
Yeah.
Yeah, no, the 11th grade is a bit hectic, but not as much as, at least it's hectic only in one way. We don't have to do like extracurriculars like how you are doing it.
Yeah. It's okay though. It is what it is.
You learn, but I don't know if it is, kind of that worth it or not. But yeah, so
Actually,
this is,
on top of that, I'm we have like these like national level competitions where like there's HOSA, which is Health Occupational Students of America. So they have like health-based competition, and then you go from regionals to state to nationals. And a lot of people do that. But at my school, we don't have it. So I'm business professional America club, and basically you have to do like a research presentation on like a certain business aspect, and then you get judged on it at the three levels. And if you make nationals, it's like really good. So me and my friends are like doing that this year, and we're trying to make nationals.
oh, okay. So what are
Yeah.
you presenting? What idea are you presenting?
We're still trying to figure out what category to do. I think I want to do like I think global marketing or small business management is interesting. But it's three other people, so obviously like we all need to decide on one together. This is my first year doing it, but I think you'd get the topic. Since it's like business, you have to think of your own ways to how you would like for small business management, like what would you do to increase the small business chances of, you know, becoming successful? And you like have to like do the whole presentation, the research, and then present it.
Mhm.
It's it's okay.
That's fine. It's something you will draw inspiration from
Yeah.
and you will learn, and yeah, that's something you will learn. It's a nice approach. I wish I had it, but yeah. I would say, if you I always used to, so I tend to observe a lot of things. That's something that I would say I'm good at, and I'm more like an introvert. Doesn't look like it, but I am. So basically, what I would do, and I used to observe, is when you look at bigger chains like Walmart, Costco, XYZ, right? There are certain things that you'll never buy from a Walmart, Costco, so and so. And in that area, when it comes to like fresh, homegrown, or whatever organic stuff, like farm to field to market and farmers market, those are the things that I would promote and have more community events compared
Yeah.
to something that a McDonald's or any big chain would not be able to replicate. So
Mhm.
that is an advantage of being a small business, because most people see that, oh, small business is very hard to survive, but there's so many advantages that come with being a small business as well,
Yeah.
right? So that's something that I would say. But anyways, so this is the presentation. So last class we went through, my hand scribbled stuff
Mhm.
to go over to help you understand what this AI stuff is. And then so I made this presentation to convince my mentor to give me resources. That's my goal, right? And make sure we get that paper published, because that girl has given up. She's not
Oh,
responding. Yeah.
I didn't think to do that.
Our postdoc told my mentor that I hope you understand that she's not employee of Pitt. So, so we can't do anything about it. But anyways, coming to what she did and why her outcomes are better, that's kind of what I wanted to show. So this is starting. This is whenever you have some image, right? Showing them the end product is will grab their attention and say that okay, this is what the end goal is. So this is the image of the hand, and there are two ways that you go with the machine learning or deep learning models, right? One is you try to detect what the image is, and the second one is what we are trying to address is try to figure out the progression. For progression, we need to be able to quantify these characteristics of the hand. If you look at the hand, you see it's mostly having rash, right? That's what you can see. And can you tell me if there are any other features that you observe in that hand
Mm,
apart from the redness? Redness is a feature.
um, I mean, I noticed that like it doesn't the finger show up, which I guess what else?
Can you
Um,
repeat?
like the fingernails, like the areas where the fingernails supposed to be are all blacked out. You
No, no, no. Just the
see,
right side, just the
oh,
hand, not anything else.
oh, that one. Um,
Yeah.
okay.
We said redness, right? One was redness. That's the rash. Anything else that you can see in that hand?
Mm,
It is a diseased hand, right? That you
yeah,
agree. So
yeah,
why would you call it a diseased hand?
because of
Because of
the excessive redness.
describe the other features apart from redness that you see. Anything. It could be. You can say that it looks more bubbly, right?
I think the areas that are highlighted seem to be like the areas of the
Mhm.
hand that aren't as smooth,
Mhm.
like the knuckles.
Yeah. Yes. What about the
And
knuckles? They're not as smooth and they look, little elevated. You would
yeah.
say that, if I touch that region of the hand, the texture might be different,
Mm,
right? So what is the second feature now I told you? One was redness, second was texture. So if there's an inconsistency in redness and texture, so that is the feature of the disease, right? That's what I was trying to look for, right? So then the second thing that I wanted to figure out was, okay, we have come up with certain features in the disease. How do we label them? That's the goal, right? So I asked my postdoc, that is the person who collected these images, to label the region of the hand which has redness. I just took redness, right? I didn't say difference in texture, right? So in our code, in k-means, we are looking at only segmenting the area, the redness in the form, in the in the picture. So it made logical sense to just segment the areas of redness, right? This is what ground truth is. This is what picture my postdoc has labeled. She has gone and highlighted, and I've extracted those highlighted regions, and I've got this image. Now, this is what I need to compare any code to. If I don't have any code for dermatomyositis, right? What is the gold standard? Nothing. There's no gold standard. Any code I write, any code that can do this will become the de facto gold standard.
mhm.
It's like, you are the slowest runner in your school, and then for some reason, no one showed up to the running race. Who's
Yeah,
going to win the running race? You.
yeah.
Right? So in the same way, that's the principle over here. I'm saying that, hey, I have taken the most obvious characteristic in the disease, right? You need to look at the disease characteristic as change in texture and any other features.
Mhm.
Texture, redness, and scaling, or any papules, or like bulges. So these are the features. I look for the prevalence of these features. Let's say I have 100 people who have been diagnosed with dermatomyositis. Of these 100 people, how many people will develop a rash? How many people will come with change in texture? How many people will come with scaling, right? So I know that 90% of the people come with rash, or 60% of people come with rash. So I
Mhm.
need to say, of the people who come with rash, this is they present with redness, right? How do I get that information? I look up the literature and I figure out what is the prevalence of this. Its prevalence is how many people in this country have already, are affected by the disease,
Mhm.
right? Then based on that, I can segment into, then I'll get the demographic features of people who are affected by the disease. I'll know their race, I'll know their blah, blah, blah. I will say that, okay, it looks like 70% are white, right? Then I'll look at, okay, if I have 100 people who have dermatomyositis, 60 people will develop the rash. Of these people who develop the rash, how many are white? Maybe, you know, 50 people are white.
Mhm.
So that's kind of what you say your code is going to solve the problem for. That should be in the first para of your introduction,
Mhm.
right? Precisely defining what what problem you're solving. So that's the introduction part, and this is what we have got. Did that make sense?
Yeah.
Now, when it comes to the second part, right? Look at the features. One is the color, second is the texture, third is the pattern. Is it oval? Is it circular? Blah, 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 whatever, right? These are the features of dermatomyositis. Now, before this code, they should be reporting these features. See, if you and I could see the feature, that is how they would have built the questionnaire also, right?
Yeah.
They would have been like, how, what is the area that the rash is covering? What is the color of the rash? What is the area that the scale is covering? And you give a score for that, right? So that's kind of what you see.
Yeah.
Does that make sense? So
Yeah.
based on what they see, they built a questionnaire, right? We are trying to replace that. So these are the general features, and the questionnaire is called C-C. And then what are the common locations? Do you see it in the face? Do you see it in the hands? Do you see it in chest? Blah, blah, blah. And what are the places that you see? So that's the thing. Now, the second thing is I also need to figure out that, okay, which is the most common place? I can see my code can only do in white people in certain places, right? I
Mhm.
need to figure out before writing the code, I should identify based on that, right? Then I need to figure out that, okay, if it is seen most commonly in the face, right? Should I go with math approach or should I go with machine learning approach? That's the question I need to ask.
Mhm.
Does it make sense? And if I say that, okay, if it's in the back and the hand, there are relatively less features I need to be worried about. When I say features, right, like eyebrow, eyes, blah, 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 those things are seen in face compared to your back and your hand, right? So it's much more easier and plainer to do your math, solve the rash segmentation through math in those regions. Next, when you look at this, right, this is something that exists. Looking at, okay, there are already tools which can figure out the features in the hand. This is the features of the hand. So I can say that, okay, this is the wrist, and this is done automatically. If you give an image or if you give a video, it can detect the features in the hand. See, but even this automatic detection, right? This feature has gone out. It's not very accurate, right? If you try to look at it in a deeper way, you'll realize that, hey, it doesn't, it looks like it is making sense, but it is not very accurate.
Mhm.
There is a scope for error. So when it comes to machine learning, right, even if you give it controlled environments, it is going to make mistakes, right? That mistake we can't control. So what were the two main things that we can do with computer code? One is disease detection, other one is disease segmentation. What is the
Yeah.
problem that we are trying to solve now? Problem of disease segmentation, which is very challenging. And we came up with a thing that, okay, I need to be able to quantify disease activity based on any model. Doesn't matter, I'm using math or machine learning. And how do I quantify it? I have a physician who has evaluated based on a questionnaire. That questionnaire was called CDASI. What are the features in that questionnaire? That is the color, that is the texture, that is the pattern, and then the other areas of the rash, right?
Mhm.
Considering all these features, they've come up with a score, and I need to comment on, then based on that score, I've classified the disease into mild, moderate, severe. Okay.
Yeah.
Now, if I take now let's say I have 100 images that are in mild, 100 images that are there in moderate, 100 images that are there in severe. What is then will it become a disease segmentation or a disease detection at that time? Mild,
Detection.
moderate, severe. Correct. Why?
Mm, because you're trying to like determine the how bad it, or like the severity of it, which is detection. Like you're trying to see.
Yes, you're trying to figure out the, disease detection. But yeah, we will go into the depths of it, but that's the overview. When it comes to disease detection, right, the model is only telling you mild, moderate, severe. You don't
Mhm.
know how it came to the answer. You know that it has been trained on 100 images which are mild, 100 images which are moderate, 100 images that are severe. That's it. You don't know what feature it is extracting, and you also don't know how it is arriving at the answer. Does that make sense?
Mhm.
Right? So that's the disease detection aspect. And like we discussed last time, the way that you make the model better is you throw more data at it and throw more compute at it. There will
Mhm.
be a point after which you are never going to get improved accuracy, no matter how much data you provide. And that is the inherent limitation of a machine learning model. Okay, so that's the one aspect. Now, when it comes to k-means, this is a very simple way to approach k-means. I told you that we are trying to segment the redness into different regions, right? K-means will assume a random value over here. Let's say the picture has a cluster which contains these two as well as this, right? K-means is it has to be the cluster has to be around here, right? And if you break it, you would have broken it like this versus this and versus this. So these two will be detected in your k-means, and this will be ignored because that is out of range for k-means, right? But that is also rash, and the only problem is it's not able to detect it, right? Then you can see that in this picture. Am I the
Yeah, stop sharing.
yeah?
Mhm.
Are you able to see it now?
Yes.
Okay, gotcha. So when it comes to k-means, right? So it's trying to do is it's trying to highlight the pixels that are around the similar regions. It will assume a mean and then whatever is close to that mean, it will, highlight. And this is also a rash, but it's not able to highlight that because it is out of that means, out of the arbitrary mean that it has assumed, right? You can see that in this example. You look at this same image, right? The image that I showed you. This redness is relatively more compared to this redness. Do you agree?
Mm-hmm.
Right? But this is also red.
Yeah.
But in our math model, we have taken a red bar and we have chopped it into different segments, right? So in this segment, I can see that, okay, this is a little bit more compared to this, blah, blah, blah. So these are all similar. So it has
Mm-hmm.
identified these similar areas of redness, but since this is out of that, range, it has not identified that. That is why it has ignored this and it has able to detect only this. Now you can ask me, right? Why don't you increase the segmentation, right? Why don't you consider the other areas of redness as well? So when I try to do that, I'll over predict. In the pursuit of increasing sensitivity, I am reducing specificity, meaning that yes, I will be able to predict, more often that this is the disease, but I will not be very confident with the area of the disease.
Mm-hmm.
Does that make sense? So this is always, I think this is the same thing that everyone faces. I have specificity and sensitivity, right? Sensitivity is every time I take the test, what is the likelihood of it being positive and me having the disease, right? So that's kind of what sensitivity is, as well as, the when you say specificity, right? I really need to confirm that I have the disease. So
Yeah.
basically, when it comes to a screening test, right? If the disease is positive, if the screening test is positive, I definitely, should go for the confirmatory test. That's how they treat in medicine, right? Now, why do they do that? If the screening test comes negative, will they ask you to take another test? Most likely, no, right? They never
Mm-hmm.
ask you to take another test. The reason they do that is if the screening test is negative, there is very less chance that you will have the disease,
Yeah.
right? Now, look at the same thing over here. If I have so much sensitivity that it is able to predict the area of the rash, right? Then I would say that, okay, if this is saying that there is no rash, then for sure I'm not going to have a rash,
Mm-hmm.
right? But can I take this result and say confidently you have, this is this is the quantity of your disease? No, that you are not able to say. That becomes your specificity. Does that make
Yeah.
sense?
Mm-hmm.
So, so this is the example, right? You are able to see time point one. This is time point, sorry, this is time point one, with day 0, and this is day 30. So you need to be able to say the code should be able to look at the area with respect to the proportion of the hand that is there in the image in both these cases and come up with an answer. I'm looking at the proportion of rash with respect to what is available over here, the image that is available over here. So
Mm-hmm.
I'm going to segment the hand out of the background and I'm going to generate a mask like this. And then I'm going to compare the difference in pixels between the two. And I'm going to do the same for this as well as this. And I'm not going to make a comparison between, this time point and this time point yet. I'm going to say that, okay, in this particular time point, when I took the whole hand and divided it by the area of the rash, area of the pixels that are the rash, then I got a number, right? And I did the same when it came to the machine generated code, machine generated image. Then
Mm-hmm.
I got a number as well. That number I'm going to compare with what I got for this time point. And I'm going to see what is the difference between the numbers. Here I'm going to do something called a p-test, or I'm going to see what is the agreement between the two tests,
Yeah.
right? So that's kind of what we are going to do. So our statistical method is what? I'm going to look for essential agreement between the two time points and between the two people at two different time points. Does that make sense? So
Mhm.
that's the overview of what the project is going to be.
Yeah.
Did you understand?
Mhm. Yeah.
Now, now, when it comes to the machine learning aspect, right, I'll tell you about disease detection over here. Very simple. We have a model which is trained to identify melanoma. Now, melanoma is skin cancer, right? The input we know that it can be black, it can be brown, blah, 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 whatever. You have to do some amount of pre-processing, meaning that you might have an image which has very high pixel value, right? 9,000 pixels, 10,000 pixels. But your models will not be able to process that amount of pixels because it will do complex vector algebra, right? So you need to compress the image into 250 to 250 pixels, right? So when you take a big image, right, and you compress it, what do you think happens to the image? Are you going to retain the features or are you going to lose some features?
Lose.
You lose some features, right? That is all. That is going to be the inherent property of any machine learning model.
Mhm.
You are going to lose features. But what's an
Yes.
advantage? You can take a smartphone which is not very capable and you can still be able to detect something, right? This machine learning is nothing but a black box. You have given some images. In our case, we have the 100 as mild, 100 as moderate, 100 as severe, and then we are passed into this model. We have done whatever pre-processing. I'll show you what augmentation is, and then we are sent it to the machine learning model code, and then it has come up with one of the three values, that is mild, moderate, or severe. These are the three things it has to come up with, right? So if it every time, see, in the first go, right, it's a black box. It can flip a coin or it can roll a dice and it can say one of the values for either. And then we have to punish it or we have to reward it. You
Yeah.
remember I told you that and then it starts at one place, it comes up with a value. If that value doesn't match what we want it to match, then we are going to change the weights and then we are going to punish it so that it comes closer to the correct value. Does it make sense? So in that's what we have done, and then it ends up with a prediction. This is one diagnosis, this is another diagnosis. This is basal cell carcinoma, dermatofibroma, melanoma, nevus, and vascular skin lesion. Okay, so
Mhm.
these are the prediction outputs that the model is generating. Now,
Yeah.
this model is publicly available, right? So we can understand what is the data set that it has been trained on. If you
Mhm.
look at the training data set, right, it's
Mhm.
nothing. Look at those number of images, 297, basal cell carcinoma is 479, 1100, blah, blah, blah. These are very few images, right? Do you agree?
Yeah.
Our data set at this point is 300 images. Our data set that we have at University of Pittsburgh. Now, what I can do is I can take our data set, give it number 8, and I'm going to call it dermatomyositis, and I'm going to input 300 images, and I'm going to augment these 300 images, meaning I'm going to say, I'm going to flip the image, change the brightness, zoom in, zoom out, all that will be considered as a different image, right?
Yeah.
When I do this augmentation, that's when I can drastically increase my data set.
Mhm.
Do you agree? So
Yeah.
in that scenario, I'm going to be able to augment the model, and I'll be able to train this model. And then when I train this model, I'm going to get a eighth prediction that will be dermatomyositis.
Mm-hmm.
Make sense? So
Yeah.
that's kind of how the machine learning thing works. So image detection we covered, how the augmentation works we covered, as well as now same thing, right? Instead of giving dermatomyositis as one, we are giving mild, moderate, severe. So based on the same principle, it should be able to detect mild, moderate, severe, right? That's how it's going to work. And what if we take any model like ChatGPT, for example, right? If we give it some input, we'll be getting some output. We don't know if it's accurate or not. We don't know how it's going to see the output or not. And based on that, we will have to see. This is an example for k-means. See, an image is nothing but collection of pixels, right? And in some areas, you're going to get more pixel density. And
Mm-hmm.
what this k-means does is it will consider whatever is close to that area as the k value, mean value, and it will highlight the pixels close to it. That's what k-means is doing. And this is how I said that you're going to get the whole hand. We
Mm-hmm.
got the area of the hand, area of the rash, and then look at the proportion between the two.
Mm-hmm.
So that's what we are going, that's what it is, that's what we are going to do. Now, what we do is, I told you that for detection, you can use a pre-trained model and train it, right? Now, you think about other ways, right? Let's say you have a model that can, do segmentation for plant diseases. Let's say you have plant fungal infection. Plant, ideally, it should look green, and this fungal infection is making it white or making it whatever color, right? Based on this, they have built a machine learning model training with, large, diverse data sets, and they've sent it into different layers. These are convolutions. Each layer is called a convolution, right? I took the learnings from that model. I just took out one layer. What was that one layer doing? It was it was trained on the color, like green and white, right?
Mm-hmm.
I made it skin color and red. I changed the feature of one layer, keeping all the other layers consistent, and I sent the image. And I trained that model on our data set.
Yeah.
Now, what did I leverage? I leveraged the learnings from another area, and I used my data set to make it better for my disease. Why it makes sense for us? Because dermatomyositis is a rare disease. If you have
Mm-hmm.
limited data set, this is your only option. So this is
Yeah.
what they do when it comes to transfer learning. Okay, you take learnings from one model and you put it to another model. And yeah, that's the overall, issue. Then we had to come up with, so the question that I had told was, these are the conditions that are similar to rash when it comes to dermatomyositis, right? We need to have a model that can identify these rashes, right? So basically, it should be like this model. We need to have a model like this, and it should have, instead of these 7 options, we need to have these options.
Mm-hmm.
Okay, so why is this better? This is better because the model has an understanding that it needs to differentiate between these things, and those features might not be in dermatomyositis. Does it make sense?
Yeah.
So that's kind of what the goal is for this project. Yeah.
Mm-hmm.
And this is what I use. This is what we were planning on using. The segment anything model is the machine learning model that was, I mean, it's not, I would say it's, yeah, it is machine learning model. This was built by Facebook, and they had trained the model on 1 billion images. 1 billion. Imagine. These are not, yeah, these are not like random, images. All the pictures that you post on Facebook is their property.
That's crazy.
So, yes. So they trained the model on all those images. And they had like people sit and label, annotate, saying that this image is hand, this image is car, so that, the model can learn. Based
Mm-hmm.
on that, it is able to segment different layers. See, it could segment this, it could segment the ring, it could segment the hand, blah, 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 right? So a big model like this is called a foundational model. Okay, now same principle. You take a model that is this capable, and then you say that, okay, I want you to be able to start segmenting the granular areas of redness, that is the rash. This is called fine-tuning a model, fine-tuning a foundational model.
Mm-hmm.
Make sense? So that's the difference when it comes to this. And see, if I used SAM, right, segment anything model on this image, it came up with this, right? Once I have this, I can eliminate the background. Now, I use the remove background model, and then because the watermark was there, this is the watermark, right? It assumed that that is the highlight and everything else is the background. This
Yeah.
is the problem with machine learning, right? This is a very small model, like 150 MB model, which can run on CPU also. That is why it is not doing a good job.
Mm-hmm.
So there are like scenarios where some things will make more sense than the other. Okay. But this model, it's very difficult to run on your laptop or any device because it consumes a lot of your graphics processing, right? So that's the thing. And then, yeah, this is another example of K-means. I would say it's doing a pretty decent job when it comes to identifying the rash, right? So whatever it is, and this is like dermatomyositis, you have muscle involvement, you have extra muscle involvement, as well as it can also cause cancer. Yeah. So this was the overview of what we have done and how you approach the writing the paper. Now you tell me, what are the what do you think we should pursue? You need to prioritize. What would you pursue first?
Mm, visual features.
Visual feature, rash, then
Mm, like, what would I pursue within this slide?
I what I'm trying to think is assume that we don't have the data set, right?
Mm-hmm.
Assume it. Now, you want to pursue this problem, right?
Mm-hmm.
How would you start?
Mm, probably with the color
You
because like
start with the color. Mhm.
if we want to identify a rash, but the model doesn't know what color the rash is, it doesn't really do anything.
Yes, that's true. And another thing, like I told last time, when it comes to like severe disease, it becomes white and there is scaling.
Mm-hmm.
So it goes from red to white,
Yeah.
right? So that time it won't be able to identify that. So it's better to, if you want to see in mild and moderate, you have to use, that's where your color is going to play a major role. So in your introduction, you need to talk about this, and in your case report, you need to stress on this feature particularly.
Mm-hmm.
Does it make sense? So when you're writing your case, you need to write about this feature and why your model could extract this better.
Okay.
Okay. So in the next class, we are going to discuss about, it's not over. We still have one more part left.
Mm-hmm.
So in the next class, what we are going to do is we are going to discuss about the other features and how to write the discussion part. Is the introduction clear? Do you have any concerns or any questions when it comes to this? Tell
No.
me what. Okay, so what is your opinion about this project?
Um, Honestly, I think it's very interesting to see how like AI and like tech is now being incorporated into medicine. Um,
Hmm.
I think it's a good starting point for like the detection of rashes, and hopefully
Hmm.
maybe in like the future it would be so advanced to the point that we're on darker skin tones that it could identify it too. But overall, like it's a very
Okay.
interesting it's a very interesting project.
Okay, got it. So this is so this is what I wanted to make addition to, right? You look at this picture, what do you see? Is the lady sitting on the chair or standing up?
Just sitting,
Yeah. And in this case, what do you see?
she's standing.
Very easy for us to differentiate, right? How
Yeah,
would you explain the computer this? How will the computer come up with an answer like what you said?
you would probably have to like build the build the pattern of
Leave
recognition.
models. Leave models. Yeah, tell me what all how would you see when you saw the picture, right? You immediately captured some features,
Hmm.
right? Some features you captured, and you need to write down what those features were, right? Did her height increase? It increased when she was standing. Now, if she is completely standing, see, even in that, right? What is the process of standing? You go like this and then you
Hmm.
stand up,
Yeah.
right? There is going to be a maximum height that
Hmm.
she can reach, right? And at some point, she'll reach that maximum height.
Yeah.
And if you take a video, right? In a video, and I ask the patient to stand up and sit down, stand up and sit down. At one point, there will be maximum height. So I
Hmm.
can say in whichever frame you get the maximum height, that is standing position. Do you agree?
Yeah.
Right? Next, when I take the sitting position, whichever frame you get the lowest height, that is the sitting position.
Hmm.
Do you agree? That is how
Yes.
you tell the machine that the patient is sitting or standing, right? The What is the cheat code way of doing it? What does ChatGPT do? Does ChatGPT understand context or
Mm-hmm.
much? You give it a prompt and you ask, is the person sitting or standing?
Hmm.
Right? ChatGPT will try to look at the billions of images it has been trained on, labeled images, and it will see that how similar is this image to the other images where they had told it is standing, right? That is what it is doing. It is predicting. It is not saying with confidence.
Hmm.
Make sense? So it can go wrong, right? There is a possibility of it going wrong. But when it comes to math, and I say that, okay, this is sitting position, that is standing position, and you're not going to go wrong with that because you did it with height, right? I could explain it. But with any of the language models or vision models, you'll never be able to explain it. These models can describe the image, right? So I took the image and I sent it to a model which was specifically trained on images. Okay. And I asked the model to describe what the person is doing in the image and asked in the prompt, is she sitting, standing, partially sitting?
Hmm.
So the output was in the image, the person is sitting down, right? Now you think about this. I have the segment anything model, which can generate masks for me. You understand the concept of a mask, right? This is like a mask. So the segment anything model can get me the right information like this. It can segment the individual out and generate a mask. Based on that, I send that mask to the other and to a different model, to AI. AI will figure out if the person is sitting or standing,
Hmm.
right? That has created a label that the patient is sitting. Okay. Next, I want to identify, okay, now we know that the patient is sitting. Now this is standing. Then what is it saying over here? I had given the prompt saying, tell me if patient is sitting, standing, blah, blah, blah. And now I told you something about how the model is coming up with the answer, right? Look at it. As indicated by the fact the girl in the image is standing and positioned near the chair. So it is describing the chair and the girl
Yeah.
because that is how it was trained. Now, using this, can I say progression? Is she partially standing, completely standing? It might not be able to describe,
Mhm.
right? So I need to use another math technique to figure out if she's sitting or standing,
Yeah.
right? So that's kind of what I wanted to do. So in looking at these machine learning models and easy stuff, right? What was the easiest part in this presentation? Doing this, getting the mask for overall, right? Now, in the same image, right, the same patient, I got a mask like this. The machine generated the mask, and then I'm looking at the frequency of change in the masks
Mhm.
in a period. Now you should go back and you should think about why are they asking the patient do the sit to stand test, right? I want to evaluate muscle activity, right?
Yeah.
How strong the patient is compared to day 0 and day 30, right?
Mhm.
If the patient is able to do the test better, it means that the patient has improved, right? So if I did not have a very quantitative way of describing this, I had to go based on checklist, right? What was the checklist? Is the patient able to do this? How many times the patient is standing up fully? Is the patient, using their hands like this to get up from the chair? What are they doing? So these were the things I used as descriptive information from me seeing the patient in the clinic to commenting about their progression
Mhm.
in disease, right? Now break it down into simpler way. I can say if the patient is, let's say, day 0, high disease activity, the frequency of change is going to be very less,
Yeah.
right? That's all I'm saying. I'm using the model to generate masks. I am using math to look at the frequency of change in the masks,
Mhm.
right? All these masks. And then I'll come up with a number. This number, quantitative number, right? I'm going to take this quantitative number and compare it to the same test and same number which I got, a number which I got after 30 days, right? Now, if the frequency of change is more in this compared to this, the first, what do you say about disease activity? Disease activity has gone down and patient is feeling better,
Mhm.
right? If the frequency of change in the first time point is less than the uh, if is more than the second time point, what would you say? Frequency of change in time point 1 is more compared to time point 2.
Wait, why would it be more in time point one again?
Sorry?
Why would it be more in time point one?
Your treatment made the patient worse, or your
Oh.
treatment is not working.
Mhm.
You're assuming that the patient will get better. Right? So that's the thing, right? Patient can get worse also. So that's the way that I wanted to implement.
Mhm.
Now you tell me if I'm doing the second way compared to doing the first way. First way was what? Asking the model to describe if the patient is sitting or standing, right? At each mask, I will ask the model to say, is the patient standing or sitting? That's all the model can come up with. right? It will never be able to quantify the information at two different time points. It will start predicting, and these predictions are going to be wrong, right? Now I can say there is a mathematical right answer to what I did. I will be more confident with my answer and I can explain the answer, right?
Mm-hmm.
So that is more, preferred. That is what is preferred. Does it make sense? Even with k-means, right? I can explain what is happening compared to, me saying that machine learning is doing something. Somehow it is predicting, right? So that's kind of the difference. Now, how it started? I started with disease segmentation. Then I learned about this rash classification, k-means, blah, blah, blah. And then I looked at machine learning, learned about the limitations in machine learning, then figured out that, okay, what is machine learning good for? Machine learning is good for eliminating the noise from outside, right? Let us use the machine learning to eliminate the noise and then use the math to quantify the change. Then based on these features that machine learning is great at eliminating noise. Math is great at arriving at the right answer with confidence. Can I use machine learning as well as math? In what scenario it will be useful,
Mm-hmm.
right? Now I'll tell you. Let's say you have a phone. I will ask you to record a 30-second image.
Mm-hmm.
Doesn't matter. At any 30-second time point, you can start, right? You'll send me the video. You would have got up at some point, right? I will start the I will start the model from the first time you got up,
Mm-hmm.
right? First time I saw you leave the chair. Once I saw that happening, then I'm going to stop within 20 seconds. I don't need 30 seconds because I can have a more quantitative approach to the problem.
Mm-hmm.
Maybe in 10 seconds only I can do it,
Yeah.
right? Because I can detect the minor changes that you have. Let's say you have arthritis, right? In day 0 and day 30, I will not be able to comment on your on dermatomyositis activity just because of the fact that you have arthritis,
Yeah.
right? But if I use this model or if I use this code, I would be able to detect the small change that you cannot capture. Does it make sense?
Mm-hmm.
So in an ideal scenario, that patient should send us video every day. And we need to keep evaluating because from, let's say, the patient does it now versus the patient doing it after 2, 3 days, there is going to be some difference. I
Mm-hmm.
want to see what the threshold is, right? So based on that, that threshold is also a correct number, right? It's a quantitative number. Like
Yeah.
how people say that blood pressure, if it's more than 140, you have high blood pressure. Same way, for this, we need to come up with a threshold. Right
Mm-hmm.
now, threshold is based on very subjective assessment.
Mm-hmm.
So how our paper is going to define, right? We are going to talk about existing ways that we are doing it, existing technology, why it is possible now, how this model is better. Does it make sense?
Yeah.
It's a lot of value add, right? Now, I'll tell you why I was thinking about it. I wanted to write a paper for my partner. Okay? Now, she's very smart academically, but she doesn't want to do research.
Mm-hmm.
Okay. A lot of difference. She'll become internal medicine doctor, blah, blah, blah. Now only this year, only she's going to apply. Then I was thinking, uh, I told her that, okay, see this, let's say in Parkinson's, most of the papers are looking at tremor.
Mm-hmm.
Okay, like tremor is increasing, tremor is decreasing. And then, what she told me? She was like, so she worked with the person who developed the developed neurology program in Rhode Island. And he's the first guy who got that movement disorder thing to Rhode Island. And he's
Mm.
75 years old and he's very influential, very precise, sticks to his time points, blah, blah, blah. Right? So she noticed certain things about those patients. Movement disorder clinic. Imagine the amount of Parkinson's patients who come over there, right? She said that everyone is looking at quantifying the disease progression based on tremors, right? But
Mhm.
that's not the only metric. We need to look at their gait, look at their activity. When they're performing an activity, what is how much they are shaking, right? Those are better metrics. Or if the patient is falling down, how many times the patient fell down. These are the things that you can't record. And these
Yeah.
are better predictors of disease progression rather than having monitoring tremor. That's what she said. So that made a lot of sense,
Mhm.
right? It's just that we are focused on wrong metrics, right? Because that is what is possible right now. And how is it really helping? And she told, let's say, you are going to quantify progression in tremor. As a
Mhm.
clinician, what can I do? Tell me. Nothing. There is literally nothing you can do. Yeah, you can
Yeah.
come up with a diagnosis. You can come up and say that, okay, the patient is getting worse, blah, blah, blah. There's no
Mhm.
treatment change. So
Mhm.
is you see, right, there are a lot of papers in Parkinson's talking about tracking progression, blah, blah, blah. But what is the implication on patient care? I would say nothing.
Wait, what does it mean by implication on patient care? Like how it affects patient care?
Yes.
Mm.
Let's say, see, I detected, right? Let's say, for example, she said that there was a patient who came to the clinic, and then he had a disease uh, where we knew that the patient is going to die, right? And the patient is going to get worse. So the physician told the person that, okay, see, you have this rare condition. Your disease is going to get worse. There is nothing we can do about it. There are no medications for it, as well as we can't even manage when it comes.
Mhm.
Now, if I track the progression of that disease in the individual, how useful is that tracking, right? Number one. Number two, let's say Parkinson's, right? In one situation, I have tracked the patient, right?
Mhm.
But I have more information that I can ask and take about disease progression compared to this, which is much simpler. And I'm not going to be changing my course of management. Okay, I will tell you where the course of management alters, right? We had one patient who we are tracking, like in our clinical trial. And we saw that, so we had sent home spirometry, basically devices to the home where we asked them to where we monitor this. Just a second, I'll try to. Oh, is it not recording?
No, it says it's
I think
recording.
it's recording, right? Okay.
Yeah.
So basically, yeah, you have the condition where you are. Okay, I'm so sorry, I lost my chain of thought. So we had sent the home spirometry where you can measure lung activity or lung values just from at your home, like how you measure blood pressure, right? You use the tool and you can measure lung volumes. So we noticed that the patient's lung volumes are going down, right? Trust me, if the patient would have been in under some other research coordinator, I don't know if they would have noticed because no one checks that information. This guy has checked it for some as part of protocol, right? And then he told that, okay, this patient, I don't know. When I asked the patient, they're saying nothing has changed clinically, but this is going down. is it like a wrong alert, or is it something, that we need to be concerned about? Then we waited. The physician, our physician, called the patient and asked him to go get a lab testing done. Why?
Mm-hmm.
Because the threshold was low, that he had to be added on a fourth drug,
Yeah.
right? Based on that value. So when he went to the lab, he got added on the fourth drug. Now, if there was no home monitoring, right, he would have never gone. And
Mm-hmm.
right, how appointments are. Like my general practitioner physician, you know what he said? He's like, yeah, everything is fine. You can come next year,
Mm-hmm.
right? Even people will say that, oh, these are the lung functions. You can come after 6 months.
Yeah.
But what if there's worsening in the third month? That was captured through the home spirometry.
Okay.
So is your device, or is your technique, or whatever you're doing, can it change the management in that manner? Is the question that we need to ask. Does it make sense?
Mm-hmm.
Yeah, so that's what I meant by, is the problem worth solving?
Mm-hmm.
That's it. So yeah,
Yeah.
that was about it for today. So you tell me, how did you feel?
Mm, I felt good. I'm glad that like my drafts have like improved since the first one I did.
Mm-hmm.
I think like the segmentation is still like, very interesting. I feel like I learned more about like the actual like process of it.
Mm-hmm.
So yeah, today was good because like before like I knew like surface level what like the k-mean clustering and what the segmentation with the what's it called with the AI models and like the computers was, but now like after today I kind of would like know more in depth.
Yeah. I think now if someone tells you like AI or blah blah blah, you will know the limitations, and you'll also understand like, okay, what is possible and what is not,
Mm-hmm.
right? At, so that is what I was aiming for when it came to this presentation. Meaning
Mm-hmm.
that when I give this, so this is what I present to my mentor and I present to people on my team, so that they all have a base level knowledge regarding what we are doing,
Mm-hmm.
right? So that no one is out of whack, or they don't understand how it works. Does it
Yeah.
make sense?
Mm-hmm.
So in the last few minutes, I kept this for the last few minutes. So you can still see my screen, right?
Yeah.
Yeah, so this is the software that is called RedCap. And in this software, what people do is, this is given, this was built by Vanderbilt University. The reason why they built this software was to make sure that data entry is secure. That's it. Data entry should be secure, right? So this is managed by Pitt. So each university takes the software license from RedCap, and then someone has to manage it. So for Pitt, Pitt also has taken a license from RedCap, and then this is the web interface for RedCap. So when you go, I'll give you the login information. You go to the projects, you go to my projects. This is how it works. And when you can create a project, or you can see one of these projects, right? I'll show you when you create a new project, right? They'll tell you it's very intuitive, right? So you
Yeah.
say that test. What is the purpose? It's for fun, practice. You need to say questionnaire, right? And then either you're starting with a blank project, or you're using a template, right? So that when you use a template, it has like different ways that you use and different stuff that you can put, right? So it will be that, okay, my cap example project, or project dashboard, blah blah blah, comes with smart tables and smart charts. So then you create the project and say, I agree, and this is the project. So you go to project home, you'll get an idea of the statistics. How many people are there? What is the space? What is the recent activity? Blah, blah, blah. All this. And this is the information. If you want to design your survey, you go to designer, click on this demographics, and then you change the fields. It's like age, ethnicity, race, gender. If you want to add a new field, you just go add field, you select type. Is it like checkboxes, true, false? Let's take true, false. What are you gonna call this? As consent. And to study. What are you gonna internally? What are you gonna keep the variable as? Consent. Is this required or not? Right? This is a field that you need to see. If not required, it's optional, right? Then you go with, is it identified? When you say identified, right? Through these surveys, you can collect social security numbers. And then these social security numbers are stored in a secure database. So that's why if you click on identifier, that information will not be exported to anyone. Okay, so that's what they say, is it like an identifier or not? And then you save it, and then this is how you add. Then you come over here. There are, see, these are all custom fields that you can add to your survey.
Yeah.
Okay, true or false, blah, blah, blah. These are the things that you can add, and you can make it whatever, right? Once this is done, you go to instruments, and then you say, either you rename, blah, 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 go here, is use this survey in this project, enable, it is not longitudinal data, you have instruments, auto numbering, and then you come to the survey distribution tool. And here it will tell that you have to enable this survey. Once you enable it, you give it the title, test. What do you want them to see first? And it will show you this information. And then you you select these features. And then what you want them to see, blah, blah, blah. Time, if you want to restrict anything, and then you save it. Once you do that, once your survey is enabled, then you go to survey distribution tool, you copy this link, and you can send it to anyone. And you see this. Consent to the study, yes or no, right? Gender, female. And then see, when it says race, right, you just need to add race. And then it will have all the drop-down options as a library. Someone has already built that. You just need to use it to develop your survey. So now you tell me, for our questionnaires that I asked you to prepare, right? This is a distribution tool. So you can send these links to your patients, and you can even create custom links, right? And say that, okay, blah, 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 and then you submit it. So you'll know that, okay, in this custom link, only this person could, complete the survey. Does it make sense?
Yeah.
So that's how we use RedCap. It's very easy. And then the reason why people like it is because it has a lot of, it's very easy to extract information from it. Data import tool, you can import data, you can export data as Excel sheet, and you can integrate it as well. So that's the main, use case for this RedCap. And the fun part about RedCap, they also have API. API is nothing but a way to interact with RedCap without having to go into RedCap, like without logging in, blah, 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 right? So if you have the authentication, I can, in Python, I can extract the information from RedCap database from my project. And then I can, do whatever I want with it with respect to I can send emails, blah, blah, blah.
Mm.
Does it make sense? So that is RedCap in short. I can create like responses or I can create individual survey links and I can also create, you know, certain fields that I pass on to RedCap. Okay.
Okay.
So RedCap is a tool that is very good to know when you have to create your surveys. So if someone, this is something that you would have to work on because most people know RedCap, right?
Mhm.
And they'll ask you to use RedCap.
Okay.
So if I would say that, if you add the fact that, oh, I've worked on RedCap, it's much more appealing and convincing to many people. Yeah, so that's
Mhm.
about it for today. Is my screen not sharing now?
Yeah.
Okay, got it. So what do you think that could have been improved?
Um, uh, I mean, nothing really. I thought the presentation was very helpful. It was like simple, but still like give me enough information that I need to understand. And obviously, like your explanations helped with that too. So, no, no negative concerns.
So let's compare last time versus this time. Last time I used pen and paper. Let's say if I hadn't used that pen and paper, would this time's explanation have been enough?
From last class, I think maybe like if you hadn't used the pen and paper, it would have been like I wouldn't have understood as well as I had. And like same with the slide
Mm-hmm.
presentation, I think that really helped because like then I can like visualize it.
Mm-hmm. Got it.
Yeah.
So this thing, if you notice, right, this same information should be compressed to 6 minutes.
The your presentation?
Yeah, we can do that. That's what our aim should be,
Okay.
right? And then how to make it into those 6 minutes is what you'll ideally have to learn,
Hmm.
right? So my suggestion, your homework is going to be you are going to take the slides that I'm going to give you. You're going to, edit whatever slides or change the slide information, and then you're going to make the presentation.
Wait,
You'll go,
edit
you
and
have to,
make changes.
and you're going to present the whole case report using the slides.
Wait, so using the presentation you presented today, I have to
You have
present
to,
the like our project.
yes, our project, correct.
Okay. Okay.
And then you have to see, it should be a pitch to why you have to do the project,
Okay.
right? So that's our start, starting pitch, meaning that you need to convince someone that this project is worthwhile. How would you convince that? And what are then the other thing is literature review. Presenting a literature review is kind of what I did. So a literature review is nothing but you go read up about the topic, understand the concept, and then you make a presentation so that others are brought to the same level as you. That is a literature review. So we come with an understanding that okay, this is what the person they don't know. We need to get them to our level. So how do we do that? Have simple slides, have presentations, and work it out, work through the storytelling. That's what is important.
Mhm.
Make sense?
Mhm.
Yeah, so
Yeah.
that's about it. I do need like I would like it if you say that, okay, what is one or two thing that you think could have been better?
Mm, I feel like maybe there was some repetition.
Hmm.
But other than that, I can't really think of anything else that
Okay, got it. Does repetition help though, or
it
no?
like for me, like it doesn't, it's not like I have, like someone has to repeat it. Like if you say it like maybe twice max, I usually like get it.
Okay, got
Yeah.
it. Yeah, that makes sense because I feel like it's a little bit harder, right? And it's something that you're not used to,
Hmm.
or someone that even I'm not used to. Like when I learned it, I was like, "Oh, it doesn't make any sense."
Hmm.
Right? And then I was like, okay, that so in anatomy, it's just information.
Yeah.
If this is called whatever, humorous, it is humorous.
Hmm.
There's no logic behind it.
Yeah.
So the person kept used to keep repeating it 3, 4 times, or it's stuck in your head. So I think I feel why repetition is not useful to you is because you also take notes and you're reviewing them. So
Hmm.
I don't think repetition is a good strategy. Yeah, I'll keep a note of that.
Okay.
But yeah, anyways, nice seeing you.
Yeah, you too. See
Yeah,
you next week.
bye.
Bye.
Mhm.
Mm.